All right, so number 5, actually, we've kind of talked about half of them. It's a naked answer equals no credit. So I'm not sure where that phrase came from exactly, but what we're talking about here is an answer with no supporting work. And so we wanted to quote you. These are the directions that students are supposed to read at the beginning of the free response section. It says, show all your work, indicate clearly the method you use, because you'll be graded on the correctness of your methods, as well as on the accuracy and completeness of your results and explanations. And this is really true. We hold students to this. The problem, or the most common time when this comes up as an issue, is on probability questions, where students can maybe do something either in their head or on their calculator, and they'll get an answer, they'll write it down without any supporting work. And at best, that's given partial credit. Okay? There is a slight exception to the rule, and that's what we've just been talking about. This question about using your stat test menu for inference questions for the do step, the p-value and test statistic, or the endpoints of the confidence interval. I put exception in quotes because it's not really a violation of this, because students in the previous step, the plan step as we call it, will have identified the procedure as, say, a 2-sample t-test or a 1-sample z-interval for a proportion or something like that. So that identification of the process is the work, is the justification for the method. And then you're just reporting the values from your calculator at that point. We've talked about the potential drawbacks, and I just wanted to add one more thing on, and that is when I'm teaching this during the year, when we're going one chapter at a time, I prefer to have kids, work with the formulas. So they get some practice, so they know how they're developed, and also so they're able to handle multiple choice questions that may focus on aspects of the formula for the test statistic or the confidence interval. All right, let's move on to number 4.
This is a common theme that my students and I talk about leading into the exam. And, many of the questions on the AP exam, students are forced to decide between which of 3 distributions are being talked about at any moment. One is the distribution of sample data. That could be quantitative data. We might be looking at a dot plot of some sample data, or it could be categorical data, and we're looking at a bar chart of some kind. Or the problem could be talking about the population distribution of some variable. And again, that variable could be categorical. So the population distribution could consist of the percent in each category, or it could be a quantitative variable. So the population distribution we could imagine might be a normal distribution. Or we could be talking about the sampling distribution of a statistic, like X bar or P hat. So that is the value of the statistic in all possible samples of the same size taken from the population. And often the sampling distribution of the statistic follows a nice normal distribution pattern approximately if certain conditions are met. So distinguishing between these 3 distributions is difficult. You have to read really carefully to see what the question is asking. But here's one example from a recent exam. Big Town Fisheries recently stocked a new lake in a city park with 2,000 fish of various sizes. The distribution of the lengths of these fish is approximately normal. Timeout. Which distribution are we talking about? Well, it sounds to me like that's all the fish. I think we're talking about the population distribution of length being a quantitative variable. And we're told that it has approximately a normal distribution. Now let's look at part A of the question. Big Town Fisheries claims that the mean length of the fish is 8 inches. So that's a claim about the population mean, mu. If the claim is true, which of the following would be more likely? A random sample of 15 fish having a mean length that is greater than 10 inches. A random sample of 50 fish having a mean length that is greater than 10 inches. Justify your answer. So this one is the tricky one. We're hearing something about a random sample, so we might be thinking about the distribution of the sample data for those 15 fish, which could be a dot plot, for example, and the same for the random sample of 50 fish. But to answer the question, we need to know how the sample means would vary in random samples of size 15, and how the sample mean would vary in random samples of size 50. So this is actually a question about the distribution of sample mean. And you can see from the scoring guide that the part A is scored essentially correct if the student says that the sample of 15 fish is more likely to have a mean length that's greater than 10, because there's going to be much more variability in sample means for samples of size 15 than for samples of size 50. Or put another way, you're more likely to get closer to the truth about the mean length of the fish if you take a larger random sample than if you take a smaller one. So you can see the justification in this problem has to be based on the variability in the sampling distribution of X bar. So all the elements are shown really nicely in this question, and I would say that on each year's exam, you're going to find at least one question like that. Okay, Josh, I think we're on to number 3.
All right, number 3 is don't write too much. This is an interesting contrast to number 5, which was make sure to justify your answer and show work and communicate. There's a fine line to be drawn between saying enough and not saying too much. So the first tip is less is more, and that is the best answers actually tend to be quite short and to the point. You don't need to go on and on. I think there's a belief that a lot of students have from their other classes, maybe an English class or a history class, that they need to write as much as possible and just dump their brains out onto the paper. That's definitely not true here. And as we've talked about, if you go on and say things that are incorrect and contradictory, you'll lose points. Okay. So the second tip, says to answer the question in context and then shut up. Be quiet. So many kids lose credit because they just keep going on, and we say in the trainings, now had they stopped after the first sentence, they would have scored E. But if we continue reading, we'll find out, and then the scores go down. The third point is that space provided on the exam is typically more than enough. There is careful thought to how the questions are laid out on the page and where parts start and where parts end. Students can use that as a rough guide, but they're almost never intended to fill the entire space. The fourth one is to avoid parallel solutions. And we've kind of referred to this already, but the idea is that students will be graded based on the weakest of their responses. So if they attempt to answer a question 2 different ways, for example, using their calculator and using a formula, students will be graded on the weakest response. That way we discourage kids from just trying thousands of different methods, hoping that one of them is correct. The next point, don't interpret the p-value or the confidence level unless asked to. We find that, as perhaps as good teaching during the year, teachers will reinforce, asking students to interpret the p-value or interpret the confidence level just as sort of regular practice. But that's not part of the 4-step process that's required for typical inference questions. By interpreting the p-value, I mean something like, assuming the null hypothesis is true, there's a such and such probability of getting results like ours or more extreme by chance alone. Or the confidence level would be if we did lots and lots of random samples of this size and computed lots and lots of intervals from those samples, about 95% of the intervals would capture the true parameter. Those are good interpretations that students should be ready to do if they're asked to, but they shouldn't volunteer those as part of a regular inference question because students honestly mess them up quite easily, and that will lower their score. The last one is to not argue with the test writers. Believe what they tell you. So if they say the conditions are met, say thank you in your head and just move on. Or if they say that everybody is going to respond to the survey, even though that may not be true in real life, if they tell you everybody will respond in the survey, then just believe it. They're trying to make it easier for the students. So don't argue with the question writers.